there's not much beyond the signal portion of this input. There's no circuitry before this. There's probably op amps and EQ filters, whatever, that may be in this. I'm not entirely sure, but we can't test any further than pin 4. None of this is irrelevant. This doesn't exist in the amplifier. It's a much more intricate circuit than just a signal. This is just an example of how it works. So we're gonna have to try and figure out where this erroneous signals are coming from. And I guess that is the next step. Alright, so I have probed these op amp outputs, and they are not outputting the correct signal to the integrated amplifier. So now I'm about to test the voltage rails on these op amps, and I have the data sheet for them. They are right here. They are low noise dual op amps. So we'll scroll down, we can see a schematic of the device, and it looks like our voltage rails are 8 and 4. So we'll have minus voltage on 4, plus voltage on 8. So we can probably say that large supply rail plus and minus 3 to 20 volts. So we would expect to see something in the realm of maybe 8 to 15 volts, maybe in there. Typically, usually see about 15 volt rails on these op amps and amplifiers. So let's go back to the microscope and let's measure a few of these devices. I'm going to try and get this right there so we can see it on the meter. I have it on DC volts, and let's go to pin 1 and see what we read. Well, let's plug it in. And let's see. That is the output pin, so I am in the wrong pin. I'm supposed to be on 4 and 8. All right, here we go. We got 0.8 volts on pin 4, which is the minus 15 volt supply. Let's check 8. And we have 15 volts, as we should. So 15 and 0.8. So we know that the negative 15 volt rail is not working properly. My guess is going to be, it is going to be this suspected circuit here that we saw earlier with these two tip 41 parts. My guess is this is the positive and negative 15 volt rails, and these diodes are two Zener diodes that are probably 15 volts. So that discoloration on the board and everything was probably a clear indicator that we have a shorted 15 volt or non-functioning 15 volt rail for the op amps to work properly. So that is going to definitely lead us back to power supply issue on the amplifier board. The power supply that does the plus and minus 20 something volt rails are the other board, and I think it takes that 20 volts and converts it down to probably 15 volts from here for the op amps. So let's pull these tip parts out and find out what's going on. Alright, so before I pull those parts out, I want to try and verify which section is not working. So we have these two transistors. One is right here and one is up here. We're going to probe these and see if we get a 20 volt in and a 15 volt plus or minus out. So let's try this pin. Nothing. That's probably the ground. 20 volts. So that is our input. And there's our plus 15. And let's try this one. 0.5, 0.5, and 0.8. So we seem to be missing the 20 volt signal here, or it's very, very low, or something shorting something down, because we're not getting anything that resembles 20 volts supplying this circuit. So we're gonna have to pull this device out, check it, make sure it's not shorted or open, and we'll probe the pads after and see if we can get that voltage back. Okay, I've taken the component out, and this middle pin and this middle pin are the rail voltages for the plus and minus 20 volts, and I do not have a connection to the minus 20 volts of the switching power supply, and I think it's due to this via crap biting us in the ass again because this supplies that circuit with the negative portion of the sine wave. Not sine wave, power supply. So right now, if I go to this pin, which is the 20 volt rail for the plus 15 volts, if I go to pin 1 on this integrated amp where it should be, it's going through a 20 ohm resistor, which is correct. So that's good. Now if I go to pin 10 and slide this down here and go to the center pin, we should get 22 ohms, which we do not. We get something in the order of some mega ohms. So if we go from here where this pad is, we get 22 ohms as we should. So like I said, this leg here, or this trace here, goes all the way down and through that via and connects up to the minus 20 volts. So we're gonna have to scab just the pin here, or this via, and just to get that minus 15 volt circuit working. The tip 42C component is okay, so we can pop that back in now that we know the issue is that via biting us again. And this is causing all sorts of trouble with this amplifier. I do not like that design, that you are relying on a via to carry all your voltages up to another portion of the circuit. I mean, it's done a lot, but I wouldn't have done it in this spot. This is a bad spot to do it. This is where a lot of heat, a lot of damage occurs, and I would not like to see that being carried to vital circuits through those vias. But it is what it is, so I'm going to put a wire through there and solder it on both sides and continue on, see if I can get those rails back up. So we're going to look for those voltages now, make sure that they're proper. So we should have plus and minus 15 volts on pin 4 and 8. So let's see what we have here. Hey, there it is, minus 15 volts and plus 15 volts. Good enough. All right, so we're looking good there. Let's move the microscope out of the way and put on just the test cam here, and let's see what we get for a signal out of this amplifier on some of these channels. Let's see if she's working. I only have a couple of channels hooked up. I just need to find them. Hey, look at that. All right. Yep, we got signal here. It's a little low. 1.2 volts there. This one here is okay. 1.2 volts. But at least we're getting something to resemble sine waves. So that's good. So we'll move on from here and go to the next problem. Alright, so what I think I'm going to do here is put that driver pack or integrated amp back into the circuit. And we know that we have some via issues in these holes going to the other side. So what I'm going to end up doing is scraping all this off and soldering it from the back side with a very fine point soldering iron. Because the other side has no traces that go off anywhere, but the solder, you solder it from that side and it's supposed to penetrate through and connect to these right here, which are not happening in certain pins. So what I'm going to do is back solder it, and that should take care of that. So I'm hoping that I can just kind of just scrape away at all this and expose some copper to solder it to. and we'll come back when we get that all prepped up. Alright, so I have those all scraped up and ready for a part to go in. I did notice it was a little bit thin here, so I scraped that back. I'm going to try and flow a little solder here. I am just going to now add some flux to these pads. And we're going to put the component down as soon as I remember where I left it. Okay, there it is. Let's try and get this down in there. Okay, seems to fit pretty good. Now we're probably going to have to zoom in here so I can see what I'm soldering. This part looks like it may have to go down a little bit further. Seems to be a little height issue here. So I'm going to pull this component back up. Pull this pad off. I did put a pad in there to try and space it, but it looks like I don't need it. Push these legs down a bit. Okay. So now to get in there and solder this up, we're going to use a curved tip to get in there a little bit easier. I'm going to just solder these devices first, or these pins first. And hope that this device is any good. Otherwise, this is really going to be a pain to pull it back out. But in this instance, we don't really have much of a choice. And that pad is shorted to that leg. That's fine. That's what it's supposed to do. There. It looks a little dark in the video, but through the microscope it's pretty light. That's all the back legs, so now we just have to go and solder all the front legs down. This is the leg that was a little messed up. Okay. Good. So now we can back out the scope and we'll try to do a continuity test between this part and the one next to it. We'll put this on continuity. Good. Hey, we have our signal back here for the ground. Well, not the ground, but the negative rail. So that's looking good. The other rail's looking good. Yeah, I think that's it. I think we'll have to go through the front here a little bit and make sure that we have our connection to this point on that second pin like we were missing before. So we'll go to the second pin and go to that outer pin here, and hopefully we have connection. And we do not. So something else is wrong there. Let's make sure the other channels. Yep. So even though, unless I wasn't connected up to this very good, let's try that again. Yeah, we got a bad, oh, there it is. It's just on the other side of the via, but it's connected. So this via needs to be, so this part's going to need to be soldered on both sides and verified, or else we're not going to get a connection from that amplifier IC there. Yeah, I guess it's time to possibly put in two output parts and see what it does. I do not have the exact part here to replace that shorted one, but I have something I can substitute in just to test it and see if it's going to fire off or not. So I'm going to solder those in, and hopefully this will fire off. So now that we have a couple of parts in there, let's remeasure that connection to pin 2 to the leg. So we're going to put one probe here and the other on this leg here, and we are good. Alright, so I think it is time to give it a power up and see what this channel does. It's either one of two things are going to happen, or actually one of three things. One, it's going to work. Two, it's not going to work. And three, we're going to have catastrophic failure. So hoping for it's going to work. Okay, so this is the moment of truth. We're going to find out if that channel has come back. We're going to let out the smoke. One of the two, I don't know. Yeah, let's power it up. And we're drawing 1.8 amps, so it's not running away, so I have hope here. So let's check the known good channels. We got 1, yep, good. We got a sine wave. 2, yep. 3, good. 4, we're good. 5, we're good. And here's the bad channel. 6, yay! All right. So that is it. We got the channel working again. So now all I have to do is just get the right components for the output, and this should be all good. Load test it, change a couple of caps, and give it a load test, and I think it's good. Yeah, so that's it. I hope you guys like this repair, and I hope you learned something from it, and have a good night.